Hello guys and welcome. In this video I'm gonna talk about a few more concepts of networking and try to paint a clear picture for the beginners. Let's talk about our first concept, the simulation. Simulation is the game world itself. It's the rules, the physics, the position of every object, the health values. It's the game logic running continuously. Now imagine you're playing a single player game. Your computer is the god of that universe. It controls the player, the enemies, the physics, the weather, everything. It's the single source of truth. There is no debate about what is happening, so simply all simulations are running on a single device. But in multiplayer games, each player is running the game on their own device, and if each player runs the game simulation, then who is going to make the decision about the game? For example, if a bullet is fired and the simulation of player A decides that it hit the target, but the simulation of player B decides that it didn't hit the target, then what should we do? So in multiplayer games, one simulation must have authority over others to make sure all players experience the same set of events. This means one simulation has the final say. It is the boss, its version of the world is the correct version. So if you have watched the previous videos, you know that we have one server and multiple clients. Now we have two options. Either we give authority to the server simulation, or we give authority to one of the clients' simulation, which in that case, that client will be called host. So having server simulation is the best type of networking because it's the most secure way, but since we are running the simulation on the server, then we need stronger hardware, so our server cost will increase. But if you decide to give authority to a client simulation, which we call host, then there will be no need to run any simulation on the server, and server is just going to relay the game data. And it only needs minimum hardware for that, which makes it very cheap. The problem with this approach is that since the host is also a client, then it increases the possibility of cheating. Also, if the host lose connection, then the game will be over unless you change the host immediately to another client, which we call it host migration, which makes things very complicated. Note that even if the server has authority, you still can give clients authority in some specific cases in order to unload some weight on the server. For example, let's actually visualize some of these scenarios. I am going to put each of these devices in a box to visualize their space. Now let's say we have a character that is being simulated in all devices. We also have server authority and server simulation. So we want to determine the character position and movement, and as I mentioned before, only one simulation must have the final say about that. Here we have two options. We can either give the client's authority to control the position, or we can keep the authority for the server. Let's say we give the authority in this specific case, which is the player movement, to the client that owns that character. Now let's say a client presses the W key and character moves. Then the client tells the server, I moved the character to this position. Then server accepts the authority of that client over the character and also moves the character in its own simulation. Then server broadcasts to other clients the new position, and finally other clients accept the server authority and move to the new position. This is actually a common practice, and a lot of famous games use this method for player position. That's why players can cheat and teleport in some of these games. It's okay though, because you can place certain checks to make sure if anybody cheats, they get banned from your game. Now, let's say you are a very sensitive person and you don't want to give any player a chance to cheat at the cost of decreasing the server performance. In that case, you can give the authority of changing the position of the character only to the server. Let's go back to the same scenario, and the same client wants to move the character. Now, when the client presses the W key to move the character, they actually send a message to the server saying I pressed the W key. Then server runs the simulation and determines the character position. After that, it broadcasts the new position to all the clients, and all the clients move to that new position. This is the safest option, but has a big issue if you are building a fast-paced game like a first-person shooter. The issue is that the data transfer between server and clients doesn't happen immediately and has a small delay. So when the client presses the W key, character doesn't move immediately and it will wait for the server for the new position. In a lot of cases, that delay in movement is going to be noticeable and make the game annoying and even unplayable. So to solve the issue, we have something called client prediction and server reconciliation. So when we have a server and client, when you send a message, it takes a few milliseconds. When the server responds to your request, it takes also a few milliseconds, and the combination of that time is called latency. So let's go through the same scenario, but this time with client prediction and server reconciliation. So this is our client. When he presses the W key, it sends a message to the server that I pressed the W. But at the same time, it moves. It doesn't wait for the server, it moves immediately. And it basically runs its own simulation and tries to predict which position the server is going to choose. Now, server also runs its own simulation and determines the position of the character. Now, server sends the position to all clients, and all the clients update the character position, and if the predicted position by the client that initiated the movement was not precise, then it will be corrected, which we call that server reconciliation. So they all accept the server authority and move to the new position that server told them. So I'm gonna finish this video here. In the next videos, I will dive deeper in the subject of networking. I hope you find this video useful. Please make sure to like the video and subscribe to the channel. Thank you for watching.